a few people. And then
Okay. Hey guys, so yeah, Friday, today is the 10th of May 2024, and this is a Friday 7 p.m. session to recap week 3 and to answer any questions anybody has got. Tomorrow morning, Saturday, we will pick up as usual 10 a.m. till 12 o'clock. So without further ado, I'm going to hand over to Abdul.
Yeah. Happy to be here once again. So, as said, we're gonna be doing the recap of what we have done so far, and maybe just introduce some concepts that we have not done. That is still in our last slide. So we're going to go through everything today. Are people already in? I can't hear you.
Yeah, we've got a few people in. So
Okay.
I think we can just start with them and others will join later.
Okay. So once again, you're welcome. I will be sharing my link. As usual, I will share my slide. Yeah.
You okay, Abdul? You can share, right?
Yeah. That's what I'm trying to do. Yeah, I hope everyone can see my slide.
Yes.
Yeah.
I can see.
Okay. In last class, we talked about dictionary. And in dictionary, we also discussed about the methods we use in dictionary, like key and stuff like that. And then get item, how we can get some items from the dictionary. And we need to know that dictionary has two values and has two elements, values and the key. So every dictionary will always has a key and at the same time has a value in it. We look into ways of declaring a dictionary. Talking about the ways of declaring a dictionary, we say we use dict method, which for some reason we were unable to get the dict method, but we were able to get that of the curly bracket. When you use curly bracket like this, you have a key like name, and then you put the value, and like age and the value. This is a way to declare a dictionary. So we talked about the method, like the get method, the update, the pop item. Those are some of the methods that we can call on a dictionary. Then after that, we went to conditional statement. In conditional statement, we said we have the if condition, if else condition, then if else condition. So like we have like 3 different conditional statements that we can always call on if we want to take a decision. If we just have to look into just one decision, if statement is enough. But when we have like 2 conditions to be considered, we have if else. But when we have a multiple condition, we have multiple conditions. We have if, else. The else condition can be as many as possible, depending on the number of conditions that we want to consider. And we demonstrated that in our Google Colab using if else, if else condition. So before we continue, I will want us to demonstrate another if condition for a score, and we give a grade to the score. So I will want us to quickly code on that and give an example of such if condition, elif condition, when we have a grade of students for students, like if the grade is between is less than 40, we should just give if the score is less than 40, we just say the grade is D. And if the score is between is greater than 40 but less than 60, we should just say E or C, credit. And if it's greater than 60, maybe we'll just say B. And between 60 to 70, let's set a condition and let's try to code such and implement. So I will use upload my Google Colabs now. I will share my Google Colab where we can practice that. Let me end this so that I can share another one. I actually want to code now, so what's wrong with this now? I can't find guts. Okay, but since I can't find, let me just open another Google Colab there. So if I have a Google Colab, okay, I hope everyone can see me, can see this. Please unmute yourself and speak so that it won't be as if I'm only speaking to myself.
Yes.
Okay, better. So now we want to consider scores such that when we put those scores, it's going to tell us that, okay, let's just say we have like 5 scores for students, like 5 students, let's just say students. Is equals to, we have list of number. So we have list of a student that scores 60, and we have another one score 57, someone score 38, another person score maybe 77, another person score 98, and another person, let's say we have another one scoring 70, maybe 81. So if we have this scores, let's say each score represents the number a score for a student. It means like we have how many students here? 1, 2, 3. Just call on the length. If you call on the length, you are going to know the number of students we have in that class. So let me change my variable name. Maybe I want to call it mathematics score. This is the score obtained by this set of students in maths. How many are they? So I don't know. If I want to know, I can easily call length for the math, length of math, length maths. Okay, if I run it, So I will know the number of students I have. I have 6 students there. What I want to do is that I want to declare a grade for them. So what is going to be their grade accordingly? For now, I don't know. If I assume that grade, math grade for them, let me just call it a variable name grade, is equals to an empty list. Here I have an empty list because I don't know what the grade is going to be. So what I can say is that if there is the score is between this and that, the grades to append maybe A. If it is greater than this, the grades to append maybe B, and if it's greater than that, the grades to append another score. So, but I don't know. Let's look into what the score can be. Let's have like 4 scores. The scores will be A, B, C, and I think maybe D or fail. Let's just say F for fail. Those are the grades. Those are the grades. So how can we assign this grade? Let's assume that the grade that will be given here is going to be a grade that is between above 80. Let's say anyone that scores above 80, someone that scores above 80, we have A. And if anyone scores above 60, so it means 60 to 80 is going to be B. And let's say between 40 to 60 is going to be 40 to 60 is going to be C, and a grade that is less than 40 is going to be less than 40 is going to be fail. So how do we implement this? We are not running this, we just only putting that to get what we're gonna use as our grade. So this is the way I will put the code. How do we do it? We can use if. If the score, we already have mass score. So if we check each scores in the mass score, every score here, each one of them, anyone that is greater than greater than 80, equal or greater than 80 should be given A. So let's use if condition. If, okay, for grade, for every score in let's call it score, the score in math score, for every score in the math score. So we are saying for all these things inside the math score, we call it score. If I like, I can say for numbers. So that's one you can decide to use anything. For number in the math score, if the number is greater than that, but if you want to call it score, we can say for score. How do we write score again? For score in math score, if the score, that is this score we use, is if the score is is less than 40, let's just start from that, is less than 40, what will happen? If the score is less than 40, what will happen? It means this our empty grade should append max grade, we call it max grade, dot append A. Okay, if it's less than 40, okay, dot append F. So it means it should any number, if this check all the numbers here, the scores inside the math score, if it is less than 40, that score will be graded as F. So, and once it's graded as F, it should just append it as dot append F inside the empty grade, because we just have the grade, we don't know what the grade is going to be. So that is the first condition. The next condition, we have used if. Let's use elif. Elif, if the score, elif score equal or greater than 40, equal or greater than, okay, let's just say, since we are, let's pick this. If it is less than 60, let's use that. If the score is less than 40, the score should be F. If the score is less than 60, now we are at 60, less or equals to 60. If the score is less or equals to 60, let's use it that way, less or equals to 60, the score should be graded. If the score is less or equals to 60, what's to happen? The math grade should give us should append, should append that score, should append C, that is credit. And again, let me just copy and paste. If the score is less or equals to 80, if it's less or equals to 80, the score should append B. I think the grade is logical enough. Then if the score is less S, because we don't have any other condition, then we use else. Else. If it is less than, we don't need any condition for else. It means we are at 80 now. Anything that is now greater than 80 will now be said to be else. The grade, the score should be A. I don't know if this is logical to you enough. Sorry. The score should be A. Please unmute yourself. Is the scoring system, is the grading system, is it logical enough? Please, let's look into that before we run it. Hello, everyone. Hello.
Hello.
Yeah.
Yes, it is.
Do you have any amendment before we, because we are saying any score that is less than 40 should be
Yes,
A.
I think it should be less than 60. C.
C should be less than 60?
Yes, then less than.
Okay, so if you say it's less than 60, okay, it means when it is 50, when it is 60, it can be considered as C, right?
It can be considered as C, yes.
Okay, yeah, so fine. But the other one we use now, it means it's going to start from 61.
Yes.
Right?
Abdul.
No.
Yeah.
Anything from 60 to 79 should be C.
Okay, it means we are not going to include equals to, right?
To it, yes.
Okay. So, it doesn't matter if I decided to call my B 81. Do you understand? But fine, I understand. We just have to follow the what we think is the conventional.
Yeah, Abdul, sorry, I have a question.
Okay.
Yeah, if you reverse the order of the grading, will it affect the results?
No, it's still the same. I understand what you are saying. So, like someone that want to think, like, let's start from the above, right? So if I say for score, let me use number this time around. For number, for num in math grade, right? math score. Oh, math score is score we are dealing with. In math score, if score, we are starting from A, right?
Yeah.
Oh, if norm, remember we are not using score again, we are not using norm. If norm is what? Is greater than 80 or, right? Is equals to, or is greater or equals to 80? Is that?
Let's just use less than 80. Let's use the exact same things we have
Okay.
above, but reverse the order, yeah.
Is less than 80, it's still going to give us the same thing. It's less than 80. Okay, what should happen? Should append, maybe we should define another one so that we don't, I want to run the two so that we don't populate this, right? Okay. So let's declare, because we run the two and see. We will not call this one grade, we call it math. Math, what can we call it?
Math grades, yeah.
And we already have grades, so I don't want
to
use that. We want to, so that we don't have to, we want to use another variable name. Okay,
grading.
Okay, grading. Math grading, yeah, so that we don't, okay. This time around, it is the grading we want to append num to. So we say num, we say math grading dot append, what are we appending here? A, right?
Hello, oh,
A.
Yeah, so we now append A. So let's just copy and paste. Oh. Oh, sorry. So we have to type, I don't know, S, elif, elif what? Num is less than what?
Num less than, I think it should be, yeah,
less than 60.
60, yeah.
So what do we append this time around? We say math grading
C
dot append
C.
Append C. And you know the reason why I'm putting the code, because you know those C, they are string, right? That is why I have to put them in the code. I hope you still remember that.
Yeah, they are strings, yeah.
Yeah. F, elif, num is less than what is again? We have done 60. It remains 40, right? That is going to be.
I think the first one should be if num is greater than 80.
Yeah.
Yeah, that's what the first one should be. Then grading should
less than
80.
Okay.
Yeah,
greater than 80.
Greater than, yeah.
Yeah. So greater, equal or greater than 80, right?
Yeah.
Equal
then
or greater than 80.
The next one should be less
than 80.
80, yeah. Then
yeah. The
then
next one should be
append B.
Append B. Okay, yeah. It means you are copying along very well. Norm is now less than what?
60 then.
It's less than 60.
Hmm.
Okay. It means we should say math
append
grading
C.
To append dot append
C.
Append C. Good. So this is just the beauty. Then we don't have any other condition. The last condition should just be else.
Else, yeah.
Since it's the last one, you don't need to give any. If every other condition has been tested and there is nothing, just say math grading dot append F. Append F. You see, if you run the first one or the second one, we're still gonna get the same thing. So it depends on your thinking, the way you just want to go about it. Sometimes you think and some thinking just come to you, you use that. And at another time you want to code again, another thinking come to you, then you use that. So there is no any static way of doing it. So let's run this. Hello. Hello, who is that? So we have run that. So after we have run it, let's try and print, because we have run the first one, let's try and now print our math grade. Math grade. Because we have run the math grade and see what we have in it. So you can see the math grade, if you print math grade and at the same time we print it together with, let's print the two. Print math grade and print, let's print the two together. Print math grade, and let's also print is it this math score? Let's print the score first before the grade so that we can see the two together and see if we have actually made any mistake. So we want to print these two. So the two, you can see the score that is 60 was appended. We now have the grade B for it. And the one that is 57, we have C. The one that is 38, we have F. The one that is 77, we have B. And then 98 is A, and 81 is also A. That is how, according to the first programming. Let's go to the second one. If we run this, because this time around, we now run this again. Then let's print the other one. We still should get the same thing. The only difference between them now is that when we want to print, we are printing a mass grading and not mass grade. Let me copy. So this one should now turn to mass grading. Please, are you there?
Yeah, I'm following.
Okay, we run this. You can see it's the same. This one, what happened? B, 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 A, A. Then our condition is not correct for the second one. So let's look into what actually happened. If num is greater or equals to 80, append A, right? If else num else num is greater than 60.
Abdul, sorry, can I come in?
Yeah.
I think what actually happened was because I was using my little knowledge of SQL to see if it will happen here. When it evaluates the first one, which is greater than or equal to 80,
yeah,
it gives you an A. Then evaluating the second condition, which is less than 60, it will evaluate it for all of the for every number in the list. And if you check, when it evaluates for the first one and evaluates for the second one, they all agree to this conditional statement. So it won't go to the next elif and it won't go to the other else.
No, where the problem is, we left a condition here because we said less than, the problem is we said less than 60.
Okay.
Yeah, we have only, we said less than 80, right? Is it 80?
Yeah, less than
the next
80.
thing should be less than 6, since we are using greater, the next one should be greater than 60. The condition has checked the one that is greater than 80. The next one should be greater than 60. The next one should be greater than, which other condition do we use?
Greater than 40.
Okay, so we omitted some things. I don't know.
Okay.
Yeah, I think that is the condition. We can just check it again.
Okay.
Yeah, we omitted some things, so I think that is the condition. Let's see.
Okay.
Is it doing it twice? 1, 2, 3, 4, 5, 6.
You can maybe because you've run it before, so it's appending again.
Yeah. Let me rerun. Let me rerun the empty math grading.
Yeah.
So what is wrong? Okay, yeah, I think it should be correct now. We have C, F, D, A,
No,
A.
it doesn't tally with the first result we have.
Okay, then it means our condition is not correct. One of them is not correct. This one is C, which is correct, right? So
no, it should be B. That's still what I'm like.
No.
The 68,
Let's see.
C,
Which condition are we using? If it is greater or equals to 80, it should be A, right?
Yeah. I think it is greater than 60, greater than equals to 60.
Should be C. Should be B.
Yeah, greater than equals to 60.
It's our condition that is not correct. So let's
Okay.
verify, let's check. If a number, this first one is correct, right? The next one is we should check for B. And for any score that will be B, will be less than will be greater than right?
Equals to 60.
Will be greater than 60.
Okay.
So if it is greater or equals to 60, right?
Yes.
It should be B.
Okay.
Of course, the first condition has been fulfilled. Then the next condition now is it is greater or equals to 60. The next one is 40, right? If it is greater or equals to 40, right? And every other one, any other condition apart from this condition will be considered as what? F. Let's try and run again. So sometimes that is why sometimes I prefer to start from the one that is okay. Is it now correct?
Yeah, it's correct.
It's correct. So just look at the condition very well.
So it was the condition.
Yeah.
I use different approach for mine.
Yeah.
And it's correct also.
Yeah. So you can use any approach. It's just the condition. You just have to. And most of the time, once you are doing things like this, always check your output. When you print, your output will guide you on what to do. So once you just use print and you print, you see the output, you can easily think on what you have done wrong. So you quickly adjust. So I think you can go either way. So either to start like this, the first condition, or to use the second condition. And you know, this elif can continue as much as you have condition. You just continually use elif till you get to the end of where the last condition we just use. Hello? What do you say?
Oh, sorry.
Okay. So that is the recall on for and if condition, which we did in our last class. So we talked about the while loop, and we also talked about the for loop on iteration. Of course, the for loop, we have also used it. We've used for loop. And we also talked about the while loop. While loop is not something that we don't always love to use, because if you use while loop and you don't set your condition very well, the while loop will continue to run. And once the condition is not fulfilled, it's going to run to infinity. So you, as much as possible, try not to use while loop, except when you don't have any other condition, any other reasons to use any other stuff. So if you can use any other stuff, you better don't use this. Just use your for loops, if loop, and every other loops, and forget about the while loop. Though it's not as if while loop is useless, you also use it. But if you are not very good, you may not be able to use the while loop, because the while loop will continue forever. So now we want to talk about user-defined functions. We've talked about many functions in the past. I think there is a function that we have not used. Before we go to the user-defined function, let's quickly go into one function that we have not used. And I think this function is going to be important for us to use. The function of the zip and the, yeah, I've seen it. So let's try to copy this to our Google Colab and use that. I hope you can see my screen. Hello?
Yes.
Yeah.
You can see the enumerate and the zip function. You see that?
Yes.
Okay, we jump it in our last class because reason why we jumped was because we have not done the for loop, and I don't just want to continually talking about the for loop why we've not done it, and we have not done the if. That is why I jumped it. Now the two functions, they are still inbuilt functions that they are very, very important when you are dealing with iterable items. So if you are dealing with iterable items or sequence, so you always love to use enumerate, and at a point you may have to use zip. So we are going to use it here now. So how do we use this? The enumerate and the zip, they are very important for us to know how to use. So let me just copy to where that stop. So how do we use the enumerate? If we have a list and we want to be talking about the each element in the list together with the index simultaneously, we can use enumerate. So when you want to be talking about, for example, I want to talk about the A, and I want to talk about the position of A. That is the index position. And at the same time, I want to talk about B, and I want to talk about the index position of B. I want to talk about C. I want to talk about the index position of C. I want to talk about D, and I want to talk about the index position of D. I can use enumerate. How do we use it? For index, that is index, you can call it anything. You can call it N. In this particular element, in this list, and at the same time, it has both the index and the value. The index of the 0 is A, and the index of 1 is B. Assuming I want to talk about a particular index, and I want the same object, I want to get it out, I can just call on the index position and get the value at the same time by the use of enumerate. So let's copy it and manipulate some of the thing we can do with it. For example, we have, okay, let me just call this. Let me copy this. If I say I have grade, if I have grade equals to this, if this is a grade. And what I want to do now is that I want to get a grade for someone in index position of okay, for index position of 3, I just say grade. For index and value in grade, we already have the name as grade. If this is my grade and I run it, and I want to get someone in index position number 3, and I want to get the score at the same time. So this is what I can just do. I will just say for index value in enumerate grade, I will now say if there is anything in this, get me the index position, get me the value of something in a particular index position. So how can I do this? So I will now say, sorry. What am I doing? Grade. I have this grade, and I know the grade has contained elements that has different index position. I want to get something in index position 3. So I can just say, if this grade, print something for me from print the value of a student on index position 3. So let me call on print. For index value in enumerate, I want to print the index position. Let me see. If we know you are using this index, let me call it index position so that we understand. if index position is equals to, let's say, at index position number 3 or 4, what should happen? Print the value. Print the value. Of course, we use value there. So we use index position and value. So if you like, you can call it for S and Y in enumerate grade. So, but since we are using index position and value, so we say print the value out. So it means if this is to print the value, we are saying index position 0, 1, 2, 3, 4. We want to print something like A. It means a student on index position at index position 4 will give us something like A. So let's see what the value will give us. What happened? Yeah, I think I run the grade. I don't know why the grade. What happens to this grade, please, everyone? I run the grade. Okay, maybe grade is let's call it grade 1. So that maybe it's not a valid name. Yeah, I think this should be a valid name now. What happens to the grade? Please, what is the problem here? For index position, I don't know what happened. Let's call enumerate. What's happened? Please check, everyone. Check what that could have been. Enumerate grade 1. This should not be underlined. I don't know why. I don't know why it's underlined this. Please, what happens to the name? Is the name not valid? Speak up, speak up. Please unmute yourself and check. Invalid syntax. Syntax in what? Okay, okay. Great. Enumerate, we are not putting the, okay, great. Grade 1, yeah. Yeah. I think this should be valid now. Okay. Now, what we are saying is that we have a list. This is the list. And in the list, we have index position, this, and that. What we want to do is take this index position and give me the value we have in it. That is what we have done with enumerate. Another thing we can do, let's still use enumerate in another way. Let's say score. Let's just get the score and do some addition. Score is equals to, we have this as a score. If I run it, so I want to perform some operation on it. So in this score, what I want to do in this score is that for index, let me call it index this time around. Please, are you there? Hello, everyone. Please speak.
Yes, we are here.
Yes, we're here.
Please, I don't like the way everywhere is silent. For index, in this, what I want us to do is that I want us to take anyone that had, I want us to take all the positive index here and add them together. And all the negative index in the positive index here, add them together, and those that are not positive, those that are maybe all index together. Okay, let's check the all index. and get them, and those that are not odd. So how do we get that? We say I want to get those on positive, no, on even index and the odd index. For if index is odd. So how do we get that the index is odd? We are going to divide the index position by 2. When we divide it by 2, the remainder, if the remainder is equals to 0, of course, you remember the modulus, right? The index divided by 2, module 2, that is, you call on modulus, module 2, if this is equal to, if the index, by the time you divide the index by 2, if is equals to 0, what should we do? If it is equals to 0, it means that it's an even number, right? So we should add the values together. Yes. If index module 2 is equals to 0, so that is the first one. By the time you divide it by 2, the remainder is still going to give us 0. So it's going to take that value and add it to, it means it's going to add 60 plus 38 plus 30 plus 98. So we now say value okay. How do we have it now? Okay, let's maybe if the index position, if this is this, let's have a sum here. A sum that is an empty sum. Maybe let's just say the sum is equals to 0 now. So what it's going to do now is that it's going to take that and now add this to value. It means we upgrade our sum. The new sum will now be the value taken. Let's just say the new sum plus the value. So okay, I think this should be the best thing we are looking for. So at the end, we can print our sum. Print sum. Hello, everyone. Please, did you understand the little thing we are trying to put together here? Hello?
Yes, yes.
Yeah. What we are trying to do is that we are looking at this score. This is the score. And when we have the score, what we want to do is like we want to take this score 60 and add this to this one and add this to the next one and then continue like that. Now, the best way we can do it is that we can take the index position. So when we take the index position, this one is going to be index position of 0, this one is going to be index position of 1, this one is going to be index position of 2, this one is going to be the index position of 3, index position of 4. So anyone, by the time this is the index position of 2, when we divide by 2, it's going to be give us the remainder of 0. Automatically, this one will give us the remainder of 0, this one will give us the remainder of 0, this one will also give us the remainder of 0. So we have been able to successfully take the value of 60, 38, and 39 to isolate them and now add them together. So these are the area where we can, condition where we can use enumerate. When we want to iterate together the value and index position at the same time. So now by the time we add them together, let's run and see what we are going to get. Oh, expected this, if, of course, at the end of if. Okay. Integer and string. Is this one a string? You know, we copied this one from somewhere. Maybe it's a string. So instead of doing that, let me just add to the value. Let me add string to it, integer to it, so that it will convert it, assuming it is a string from where it's coming from. I'm not sure if it's a string. Oh, please, can you tell me what we are taking grade 1 instead of taking score? Yeah. Is the score that we are using not grade 1? Please, let's turn this to score. So, because it is this score we are using, we have defined a grade 1 somewhere else. And because we copied the code, so we are now using the grade. Okay. Expected this at the back of this, okay? And then by the time you run, you should be able to get the sum. So what happened now is that this take 190, we'll have 196. We have 60 plus 38 plus 98. Let's quickly add that manually and see if that is going to be correct. 60 plus 38 plus 98 and see if that is what has been taken. That is 196. You know, if we have lots, if you have thousands of numbers here, that is how we will be able to iterate one over the other. If we want this one, what we are going to do is that we just change this condition to 1. Because the remainder will be this is in the position of 0, this is in the position of 1. 1 divided by 2 will give you 0, the remainder 1. So it means it's going to be taking every one that has a remainder of 1. If you change this condition to 1 now, it's going to be 57 plus 78 plus 81. That's the output that we are going to get. So you can see the output has changed to 215. This is a condition where we can use enumerate. So we use enumerate to get to iterate on both the index position and the value. Let's talk about this other one, the zip. It's very important because we are going to be using this a lot, especially the zip. Let's look into this. In this one, we are considering two numbers. Let's say we have a list 1 and we also have a list 2. We are looking into operation that we can do in both list 1 and list 2. We might decide to be saying for every number in list 1 and list 2, add the first number to the second number, add this one to this one to that, and this to this. So we can achieve so many things in this in this programming. So like what this is going to give us is telling us that if we call this S and Y, we are saying the first number in S, we call it A. Every number in S, we denote them using A, and every number in Y, we denote them using B. We say X and Y, that is from S, it means A is from S and Y is from, and B is from Y. But if you change it to the other way around, I will change this one to Y and this to S. It means A will correspond to Y, while B will correspond to X. So that is what it means. So now we are saying for A in Y and for B for A in S and for B in Y, what should happen? Print A. A will definitely give you 1. B will give you 5. A plus B will be 1 plus 5. And A times B will be 1 times 5. And if you go again and go to the next one, 2, then the next one is B. Then another thing is going to be A plus B. That is 2 times 6. And another one will be 2 times 6. So if we run this, we definitely going to get okay, let's quickly run. Since I copied this, it's going to contain a lot of error. You can see, so I don't want the error, so it will give us error. Okay, I think the error has gone. So if you run this now, the output should be 1, 5, 1 times 5, and then 1 plus 5. So if we run it, this is what we are going to get. This first one is telling us the first one is 1. The first one in S is 1. The first one in Y is 5. That is 1 and 5. Then 1 A plus B, that is 1 plus 5, which is 6. That is the next one is A times B, that is 5, 1 times 5, which is 5. That is how it runs it for everything. You are not going to understand this one very well as much as let me give you another example that we understand. Please, can you see my screen? Can you see my screen?
Yes.
Yeah. So I want us to run this. Let this be an assignment. Okay, let's quickly do this. And if anybody has if you are having your system with you, let's quickly do this. These are the score of some students in mathematics. Let's call it math score. Math score. And let's leave it the way it is anyway. Math score, chemistry score, and biology score. Now, I want to grade it. I want to get the total score for every student. So let's say total score. Total score. I think there should be something like average score, right? Okay, let's find average. Yes. Let's find average for every student. Let the average be equal to this empty list. Let the total score be this empty list. Please, who want to give us the idea on how to get this? What I mean by average is like average of a student. A student that scores 76, and again scores 75. So the average of this student is going to be 76 plus 76 plus 75 divided by 3. Why the total score is going to be 76 plus 76 plus 75? Yes. Please, how did you think we are going to achieve all this? Let someone tell us how we can do that. Hello, everyone. Hello.
Hi.
Yeah, please, how did you think we can do this to get the average for every student?
Let me try.
Or total score, yeah. Got the total score first.
Math score with we can represent it X, Y, Z.
Okay, S, Y, Z. How did you say we should do it?
Yeah, with zip.
Okay, we say for S,
Y, Z.
okay, Y,
X, Y,
Z,
Z,
and
zip.
Zip what?
In zip. And chem score.
Sorry. Yes. Okay. Chemistry.
Math score. Chem score.
Okay. It means if you are starting with math score, it means your S is math, right?
Y, yes.
Your Y is
Chem score.
And your Z, is your biology score, right?
Yes.
So even if you like, instead of saying S, Y, Z, you can say math, chem, bio. Do you understand? Okay, great. So if this is this, what should we now do? We should now say what should now happen now? Your total score now should now be
Total
score dot append, because total score was empty before, right? So dot append S plus Y plus Z. I hope you get that.
Yes.
Your total score now should now be, when you have taken, it means if you are taking this from math and you take this from chemistry and you take this one from biology as S, Y, Z, what should you do to them? Add them together. S plus Y plus Z. So when you append it, it's going to do that for the first person, then do this for the second one, do this for the third person, and go on and on. So it means we have the total score. Now, if you now have the total score like that, what should you do to the average? The average should now be append. You now be average dot append. I want to do the two at the same time. Average dot append. What did you think should be appended? We now take the total score you get here. You know the total score we automatically increment. Have a value. We now take the value and divide by 3. I think that should be the average, right?
Yes.
So this now will now be the total score you appended. That is total score. Total score. Total score may not work because we did not give the total score as a variable.
The variable name, yeah.
Yes, it may not work. So we can outsmart it and call it total score here. Total score. Let's call it something else. Maybe let's just call it sum. Sum to be equals to S plus what I copied. I hope you understand. So inside this place now, we just put sum because we already have it as a variable name. Now it's going to be easier for us to just come to the variable into the average score and say dot append sum. I hope you understand. Sum divided by 3. Is that clear enough? So if we run, let's run the first one, then we can run the second one. Now we can happily print our total score, and at the same time print our, what do you call it, our average. So if we run that, we should get the 2. You can see the total score for the first student, we have 227, 178, 261, 221, 191, this, and the average is 95, 59, 87, 73, 62, and from here you might decide to say, okay, if someone is between the average of this and that, you can still have some grading system. If you are within the average of this and that, you say first class. If the average is greater than this or less than this, you say second class, lower, or upper, and like that. So you can see we have been able to use the SIP to do some manipulation of our what do you call it? Our list. Please, did you understand?
Yes, please. Sorry, I have a question.
Yeah.
Yeah. What if in a situation whereby the subjects are more than 10 or 20? We don't are more than 20. We don't want to count it, but we want to automate it. I want to call up the average. We don't want to use sum divided by 3. We just want to get the average.
Yes, you can use that. You if you want to do that, you call on maths. There is a Python library that is called maths. You understand? Because we did not call on them, because we did not do the Python library, that is why I didn't bother to talk about it. Okay. So we have a Python library, we say import math. Okay. So when you import math, you can do so many operations on math. For example, if we have this, let's try that. Let's just try this. And so if I run this now, and I want to call on average, maybe some average, I don't know, average of, I don't know. Let me check the notation and quickly let me check how we run the math. So that for someone that want to use it without calling on sum, this and that, you want to sum some of these things together. There is a lot of some of these mathematics functions we use. So average, I don't know if you use dot, or we use bracket. Maybe let me call bow score. Let me see if that is gonna work. Dot average. I'm not sure if that is gonna be the notation. It's not working. Dot average, or maybe I do average and put bow in this. So since we didn't do it, that is why I didn't bother to talk about that. So I know you can do that. Let me see if it's gonna work. It's not working, maybe for the list. I don't know. With time, if we would need that, I will look for the math functions, how to use the math function, and then we run through it. I understand what you're talking about. Okay? Are you with me?
Yes, I'm with you.
Yes, see, there is a library we must import, and I think that library is math. So, and sometimes I think it doesn't even work on list. It works on NumPy. Yes, it works on NumPy. So I don't think it works with list. I think it works with NumPy. So since we are not using it, that is why I didn't bother to talk about it. So let's quickly look into some other things that we are supposed to be doing. We have done the enumerate and SIP function. I'm sure you now understand. Then we want to talk about user-defined functions. There are functions that we have been using inbuilt functions like the print functions and every other functions, all the functions we have been dealing with, they are all user-defined functions. So we are saying we can get our own functions and use them. How do we define functions in Python? Because the way we do in Python is different from the way you do for JavaScript. So if for Python, this is the way we give the function. You always use the def. If I want to have a function, I will only say def. You can call it anything, my function. Maybe a function to calculate something or a function to do something, then you put this and go there. Any other thing you want to do, you give it inside this function. This is how to give a function, how to declare a function or define a function. Let's look into a function that we can define. Let's try to get a function that can print odd number from set of numbers. Odd number from set of number. So if we have a set of number like list or list of numbers, let this be the list of number is equals to maybe list 2. Let's just call it anything we like. List 2 is equals to, if we have list 2 is equals to so this is a list of number, and we want to have a function that's return the that always return, what we call it, that always return the odd number in the number we have given. So what we can do is that we can say, okay, give a function. This is our function. In this function, we want a number. We want the odd number from the function. How can we do that? We can say for number in list of number, let's just call it the list 2. For numbers in list 2, what will happen? Let's divide the number by 2. So we just say the num divided by 2, the modulus division divided by 2. If this num is equal to 1, automatically the number is an odd number. Then we say print odd number. Or maybe we append it somewhere. We say odd number, for example. Odd number. Odd number is equal to empty list. So we say if this number, if num divided by 2 is equal to 1, it means the number is going to be an odd number. So we're just going to say append that number into odd number dot append. So it's going to append that into that, and that is the end. So what you're gonna do after you are done, you can say the function should return the odd number. So you can use return or you say print. So it's another way of saying print the odd number you have. So that is going to be what the function is. If I run this function, the function is already, oh, what happened? Invalid. What happened? Okay, it's equals to 1. Let's see. Because this time around it's not string. I don't get it. Cannot assign to expression here. Maybe you meant is equals to, yeah, I've used that. Assignment. Then please, what is the problem? For number is this, okay, if for number in this, if I didn't put if, yeah, if number is equals to this, please, you should always go along with me, or this you should be able to. So at the end, just return the odd number. So when you run, this will return the odd number for us. So we have run the function. If I call the function, you can always call the function by the function name. This is the function name. If I just come down and type this function name and run it, it's going to print all the, what happens again? List.append take exactly 1 argument. Yeah, I didn't put any argument. Yeah. It was an empty one. Hello, everyone. Hello.
Hello, yeah, we're here. We're with you.
Yeah. So please, this I put this one so that we can use it to understand the list can come from outside because the list should be something that we are going to put because you don't know what the list should be. So the list should be coming from somewhere. So you can call the list anything, like maybe you just call it list. Let me see let me see the initial this thing I copied so that we can use it to explain. We have the function. This is the function name. And the function sometimes takes parameters. Sometimes it doesn't take any parameters. So when you are calling it, if it's taking parameters, you are going to call it with an argument. So if it takes a parameter, so the parameter that's supposed to go in to be what you want to use. For example, I want to use a list. So the parameter that should now go in should now be the list. So if the parameter I'm using is a list, let me just copy the list out. There is nothing in, we don't know what that is going to be. So let this just be a list 1. That is what let me just call it list. Maybe that is what I want to call it. So it means when this function see any list, the function will take the list and take the item in the list, divide it by 2, but the list is what we don't know. So what we can do is that now that we have run it, we are going to get a list for ourselves and say, okay, this is my list. Use the function to get whatsoever the parameters is going to be. So you're now going to run this. Once you run this, then you now call the function. This is the function's name. So by the time you call the function name like this, you now pass the list into it as an argument. So once you run it, it's going to use, what happened? What happened? Give a 0. I don't know. I don't know what the problem is. By now, this should be able to use this list and get all the odd number from it. But I don't know why it's not, okay, since I have a return, let me use print. Maybe want to call for print. Let me rerun everything. Sometimes your indentation can also be a problem. Yeah, you should not indent it properly. This is where the function comes from. So let me now say it should print my odd number for me. Odd number. So if I run this again, so since I now pass a list in it, you will now call the function by passing there whatsoever you want to use. I call it my function. Yeah, fine. So let me run it. If I run it after that, we're gonna go through it again. I now pass a function across to it. I don't know. What is wrong? Something is wrong here. Who want to please look into it very well? Do you have anything you want to tell me, please? Check it for me. Please, are you checking it? Hello?
Yes.
Yeah, please check if I make mistake anywhere, so that we can just look into it together. It's supposed to print out the list. Are you still seeing my Google Colab? Hello? Hello, everyone?
Hello.
Are you seeing my Google Colab?
Yes.
Okay, please, what do you think is wrong? Because there is a mistake and I can't decode. So find it out. Let me stop sharing so that you tell me whatsoever you get. And so please, let's try to find what the problem is. I'm sure you understand what I mean by defining the what do you call it? By defining the function. Let me get one of my code and bring it up. so that we look into it together and see where the problems lie. Let me just copy a code. We look into it together so that we, in a way.
Hey guys, sorry to be the bearer of bad news, but we've got till 8:45 for a hard stop. Blaze isn't here to support me and Abdul, and I've got to leave the house where I am. So at 8:45, so that'll be the hard stop. Unless you want to end it, Rahul, Abdul.
Okay. So we should just use like the next 10 minutes or 20 minutes to be done with our function so that we can end the class.
Okay, so do you want me to come back for 8:45? I need, and end it then, or do you want to end
Let's
this?
wait till yeah, maybe you'll come back.
What, 8:45? Yeah.
Yeah.
Okay, cool. All right, guys. See you shortly. Enjoy. Only 1, 2, 3, 5 of them in there. 2, 3, 4.
Hello, are you with me?
Yeah, we are with you.
Yeah, so let's go back and share the stuff. Were you able to decode any stuff?
Oh, yeah.
Let's go through the Google Colab. I just copy a simple code, one of my simple code, so that we look into it and see. Oh no, not this. Okay. Let's look into this code. If you have this function, for example, this is the function, and the function says def random phrase, user phrase, print user phrase, all the stuff, and at the end, you are to enter random phrase, for example, and you do this, you enter the random phrase, any phrase you like. I'm here with you. This is a function name. This is the parameter that is going to take. It's going to take a random phrase. And what will happen is that you should print this anytime you call the function random phrase. So after you do that, let's enter. So I put, hi, I'm here with you. So immediately I go back and I go and call this function. If I call this function now, if I run it, it's not. What is wrong?
I think you should run random phrase.
Yeah, I run.
Yeah, just that.
No, you are okay. Let me see. Let me just say, let me call it using let me just call it using my words, for example. Let me assign it to something. Variable is equals to random phrase. Okay. But that is not the problem. You know, the problem is that we are putting a string, and we are not putting the string inside the code. So if I'm calling that user phrase, that is what I use. But if I'm not using a user phrase, I can use anything I like. Let me say, if I put joy, and I run it, it's going to put joy in whatsoever I put. But we are not yet getting the function stuff the way it's supposed to be. So I don't know. We have to go through the functions again, and let me copy it again, and then we look into the proper way of giving a function. The function is not well explained yet. So let me copy another function out. Okay, I got another function. So we have a function here that we call add a number. So we are saying this should add the two numbers together, the function that will be adding two numbers together. So it has the parameters, the first parameters and the second parameters. So this is how to give the definition of our function, def. And what's the function name? The function name is add. And the parameter is taken is num1, num2. So what should happen to num1 and num2? The num1 and num2 should be added together. We are saying return num1 plus num2. Instead of using return, we could have said print num1 plus num2. After we have given that, now if this is our function, this is the function. If I run it, so we can call for the function. This is now the function. We call a function and we call it some value, and we say add. This is the function name. What is it adding? Num1 and num2. So we put a number that we want to be added. So by the time you run it, it's going to run it. Then when you say print some value now, this should definitely give us 30 print, or you just say some value. This will give us 30. So this is just an advanced way of using a function, if you are using all this if stuff, etc. So you can actually use a function that define a function for yourself. Although you understand that we can just do this without even calling on a function, but we just want us to have an idea of what a function look like. Though we're not going to be talking about functions as a data scientist. We are not going to be talking much about functions and class, but we just want to mention this so that in case you want to go in depth into Python and you are coming across functions and class, these are things you definitely going to be seeing. Another thing is that let's add another one. If we are not using some value, let's turn the sum value to maybe like 100 and minus 20. If you run this, we should get something like 80. So run this, call on some value again. So it's just a way of reusing our code severally. You can see we get 80. So it means we can continually reuse this code as long as we want. So let's go to this one. I don't know what actually happened in this one that we cannot run what we want. So let's see. Let's go back to the one that was giving us a problem. If we have this as our function, let's copy it and go down. I don't know. Sometimes if we have this as our
So
function, and the function should be a list. If function is a list, and we add odd number as an empty list, and we say for number in this list, that is this list that is here, what will happen if we have a list here, and this is what the list look like? We say if the number in the list, if you divide it by 2 and you get a remainder of 1, you should append the odd number inside the odd number. So, and at the end, that should return an odd number. So if that is what our function look like, we should be able to now call for a particular list. If this is a list now, and we pass the list in a function, in this function, let me run it again. So we have a list, and this list now, we now want to pass it in this function. So we call on this function. This is the function, and we now put this list name inside the function. That should be able to print the odd number for us. And if you are not getting it, we move forward and continue, and I don't know what the problem is. I don't know. So if I'm able to get it next time, we coming back to it. I don't know why. I don't know. Sometimes it's just going to be a little thing for us to adjust, but since we can't get it now, don't let us waste the time on that. Let's continue. And the next thing on our slide, because tomorrow we have tomorrow, by tomorrow we have what is called scope. The scope is just about talking about variables. When you have a variable, there are some variables that can be that are said to be global, and there are some variables that are said to be local. If we have a function like this kind of function here, and inside this function now, we now have a variable defined in this body. The function is going to be a local variable because the function is inside the function. The variable is inside the function. There is no any other variable. There is no any way you can call for the variable outside this function. So because you cannot use the variable outside the function, it is called a local variable. But there is a variable that when it is outside the function you define, you can still use it elsewhere. Such a variable is going to be referred to as a global variable. So let's just pause on that. When next class, when I will revise on before we move into the real work of the day, when I revise on them, we are going to still talk about this local and global variable. We have what is called higher functions. The higher functions, they are also they are not user defined. They are majorly building functions that takes in another function, a function taking in functions. So those are what we call higher functions. For now, we may not be able to go into them, but as much as we have any reasons to talk about the map, the other time we talked about the SIP and the enumerate, that's because I believe we can now understand. That was why I went back to bring them in after we have talked about the if and for condition. The same way, when we get to where you will understand the map and the filter together would reduce very well, then I will talk about them again. So let's just continue on this. And because our time is going, we may not be able to do much again on the class and exception. So let's just jump to downloading and installing the data science library, because that is the aim. But don't think we are not going to come back to all this. Once we talked about this one tomorrow and we are done, we will go back to part of this our slide that we have not done. So I want us to actually do our installation before we go today. So please, everyone, let's quickly go into an installation of to download Python and install Python in our system. So, you know, we have been using Google Colabs. But now we want to use Visual Studio Code. So how do we do that? Hello, everyone. Hello.
Yes.
Yes, we are with you.
Okay, yeah, so let's go into that. So what we're gonna do is that we are going to check on our system. In our system, we should be able to run PowerShell if you are using Windows. You have PowerShell on your window, so go into that. Search for PowerShell. Are you there?
Yeah, I've installed mine already.
So if you're on your PowerShell, you should be with me like around here. This is how your PowerShell should look like. Can you see my window? Can you see that?
Yes.
Yes.
Okay. So if you have your PowerShell, just type Python and let's see. You type Python. Have you typed Python? Are you there? Hello?
Hello, we are with you.
Yeah, have you typed Python on your system?
Yes, I have it on my system already.
Okay. So if you have Python on your system, you can install some libraries. So when you have Python on your system, there are some libraries we want to talk about, like NumPy. So you can say pip install NumPy. pip install NumPy. Have you done that? Then you enter it. Okay, what happened? Pip install num. Oh, my spelling is wrong. NumPy. NumPy. But my spelling is not wrong. What is wrong? Pip install NumPy. You try to run that on your system. Is it running? Pip install.
I think it's running.
It's running, right?
Yeah, it's loading.
I don't know what's wrong with my system. You type pip install NumPy, right?
Yeah, I just type it, but it hasn't bring anything.
Install. What is wrong? Pip install. Invalid syntax. Is install not correct? Check my spelling for me on your system.
It's correct.
So, and you type the same thing that's running on your system.
Hey guys, I feel so bad. There's only a few in here, so I don't feel too bad. But I've got to get out of here in about 2 minutes. So
okay. So you're welcome back. So now we are trying to try to install, but for the purpose of tomorrow's lessons, I will say we try to install all this we have on our slide. So before tomorrow, please let us try to install, use pip install numpy, pip install pandas, pip install open pysy, okay? Then pip install Jupyter. So let's try to do all this before tomorrow on our system. So you go to your PowerShell. When you go to the PowerShell, you type Python to know you have Python on your system. You can actually check the Python version by running a Python version on the system to know the Python version that is on your system. Then after that, you run pip install to install some of these libraries like NumPy, Pandas. Tomorrow we're gonna add some of the things we are to install, and then you also install Jupyter. So the Jupyter notebook is the one that we install the Jupyter notebook. Then you download Visual Studio Code, PS Code from the web and install on your system. So that is going to be what we primarily work on tomorrow, for tomorrow. So I think we can stop here today. So if there is anything we have not done today, we just quickly recap tomorrow, and then we jump into all those libraries. Thank you.
Cool, guys, amazing. And it's like 1, 2, 3, 4, 5 of you. Incredible for your dedication to this. So it's great. Abdul, thank you so much. Apologies, I've got to cut it short. But I hope we see all of you again tomorrow morning.